Midpoint theorem. So what is the theorem talking about? The line segment joining the midpoints of two sides of a triangle is parallel to the third side. So let me explain with an example. I have a triangle ABC. Say this is 10 centimeter length and this is of 12 centimeter length. So I pick a point P, which is around 5 centimeter away from both the ends. So this is 5 and this is 5. So this is point P. And I pick one more point, say over here, which is 6 centimeter from both the ends. And so when I join them, right, we'll call this as Q. PQ will be parallel to BC. That's what the midpoint theorem tells. That is, if we have a set of points and these points are midpoint of these two sides, and the line joining these 2 points will be parallel to the third side. So it is true for all the cases. If you take midpoint over here, if I join this, let me do this. If I join this, like say this is N, Pn will be parallel to AC. Okay, so this is something that you guys have to realize. Now the converse of the midpoint theorem, that is the ulta. The line drawn through the midpoints of one side of a triangle parallel to the other side bisects the third side. So let me explain this. Again, we have ABC and this is a midpoint. Okay, so now if I happen to draw a line which is parallel to the third side and this point of intersection is Q, then we can tell that AQ is equal to QC. Okay, so this is by default parallel to this. I mean, as per the theorem, if we have this to be parallel to this and this to be the midpoint, so all these are given. This is the conclusion. No? You got it? Here the conclusion is things being parallel. Here the conclusion is AQ is equal to QC. So that's the difference. So let me explain it. If P comma Q are midpoints of AB comma BAC respectively, this implies PQ is parallel to BC. So that's the implication. Here, please understand the difference. If P is midpoint and PQ is parallel to BC, then Q is midpoint of AC. Okay, so this is your difference and these are your theorems.